Imagine living on the moon. Sounds like science fiction, right? But what if I told you that tiny 100-gram bricks could be the key to building humanity's first lunar habitats? China is making huge strides towards this incredible goal, and the results of their latest experiment are nothing short of astonishing. Just last week, the Shenzhou 21 spacecraft returned to Earth, carrying with it a precious cargo, the first ever lunar soil bricks, to have spent a year exposed to the unforgiving environment of space. These aren't your average construction materials. They're experimental blocks designed to mimic the composition of lunar regolith, that is, moon dirt. They were sent up to the Chinese space station as part of a groundbreaking experiment. These specially crafted bricks hitched a ride back alongside 3 astronauts who had just completed a 6-month mission. The initial inspections are in, and get this, the samples appear to have survived their year in orbit remarkably well. Scientists are calling it a promising early proof of concept for future lunar construction. This is a major step. Upon opening the lid, we found that the samples were in good condition. There were no dents, holes, or other visible defects that we thought they might have because of impacts by meteorites or space debris, explained Zhou Yan, an associate professor at Huazhong University of Science and Technology in Wuhan. Besides, their colors looked slightly lighter than before. It requires further assessments to figure out the reason, he added. So, they survived the harsh conditions but changed color. Intriguing, right? Let's dive into the details. These 34 returned blocks, each a mere 100 grams, were created using materials carefully designed to replicate the composition of lunar regolith. The secret to their strength lies in the manufacturing process: hot pressing, electromagnetic induction, and microwave sintering. These advanced techniques give the bricks a compressive strength, about 3 times greater than regular bricks. This is crucial because lunar habitats need to withstand extreme temperatures, radiation, and micrometeoroid impacts. Could these tiny bricks really unlock China's lunar ambitions? Absolutely, but here's where it gets controversial. Some experts argue that relying solely on lunar soil might limit the design and durability of lunar structures. Others suggest that a combination of lunar resources and materials transported from Earth would be a more viable approach. What do you think? Some of the samples that we sent into space were complete, while some had 45-degree symmetrical seams that we made in advance. By doing so, we wanted to see what changes they will undergo in terms of their mechanical properties after a year on the space station, shared Qin Yiheng, a graduate student involved in the project. This clever approach allows researchers to study how stress and strain affect the bricks over time. Smart. Beyond mechanical strength, the experiment is also rigorously testing how the bricks hold up in terms of thermal behavior and radiation resistance after prolonged exposure. And this is the part most people miss. A parallel control group of identical bricks is being kept right here on Earth. This allows the researchers to directly compare the space-exposed bricks with the control group, pinpointing exactly how the unique conditions of space alter the material's properties. It's all about having a baseline for comparison. After the return of the 3rd batch of samples, based on more horizontal comparisons, we may be able to discover a pattern and ultimately build a model so that we can predict what they will look like after 5, 10, or 20 years of service, and eventually we can even forecast possible changes in a lunar environment through this analysis, Joe added. This long-term vision is essential for planning sustainable lunar habitats. China's lunar program is incredibly ambitious, aiming to land astronauts on the moon by 2030. And construct a basic version of its planned International Lunar Research Station by 2035. Talk about a tight timeline. To make this dream a reality, China plans to minimize the immense cost of transporting materials from Earth. The solution? Relying heavily on in-situ resources, meaning resources found directly on the moon. This includes lunar soil, solar energy, and surface minerals. It's a bold strategy, but if successful, it could revolutionize space exploration and pave the way for a permanent human presence on the moon. So, what do you think? Are these lunar soil bricks the future of space construction? Is relying solely on in-situ resources a viable strategy? Or should we be exploring alternative approaches? Share your thoughts in the comments below. Let's discuss the possibilities and challenges of building a home away from home.